Okay, so now we are going to discuss sums, and also we have one more part, okay, in this relation itself, that is going to be inverse relation, that we have to discuss. Okay, inverse relation we will discuss. Then also we'll be seeing a slight difference between inverse relation and then the inverse function. Then yeah, then the relation topic itself will be completed, and also we will have some sums. We'll be doing those sums also. And I said to you all that we can prove that this is transitive. There is actually no proof. Okay, there is no physical proof. You can just assume. Okay, this is transitive according to tri-value. Okay, tri-value is where like an assumption you have made, and that is actually correct. Okay, that's it. That is what we will be saying as tri-value. By that only we can say that it is transitive. Okay, let it be. Now what we are going to do is we are going to solve one sum. Then after that we are going to proceed with inverse relation. Okay, so the given R, okay, so that means the first set, okay, they have given set A is equal to 1, 2, 3. Okay, and then the relation R is equal to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Sorry. Oh, what am I writing? 1, 2, 2, 3, 1, 3. What is that noise? Okay, so I think that I've fixed the problem. That noise. Okay. And the question is that we have to find whether is this transitive or reflexive or symmetric. Okay, so first we will be, till now we have discussed 4 different relations, right? And also there are still some other types such as universal relation, but that's not required. Okay, like null relation, that's also not required, and we will not get any questions. Okay, so first is we will first check whether it is identity relation or not. Okay, so A. So identity relation. In order to check whether it is identity relation or not, what is the thing? I've already explained what is identity relation. You can see, if in case it should be identity relation, then what should be this relation be? Then R should be 1, 1, 2, 2, 3, 3. That's it. Okay, only this should be there. Then only we'll be saying that this is an identity relation, or else no. Is there? See, this is there. Okay, so this is there, but along with that, still some other ordered pairs are there, like 1, 2, like 2, 3, and then 1, 3. Like that, it is there, right? So hence we can say that this is not. Sorry, this relation is not an identity relation. Okay. So next is we have to find whether it is symmetric or not. Symmetric relation or not. Okay, so what is the symmetric relation? That means where if A is related to B, if A is related to B, then B should be also related to A. Okay, if this condition is there. Okay, if this condition is there, then we can say that it is a symmetric relation. That is what we have seen over here, right? Like here I've written in terms of relation, or also we can write like this, which is A comma B and then B comma A. This is what we have seen here. C. Okay, now we are going to check that only. Okay, so here what you have to do is, when you are checking whether one is symmetric or not, okay, whether a relation is symmetric or not, whether a relation is transitive or not, you have to neglect these 3. Okay, you have to neglect these 3. Then only you have to proceed with the checking itself. Okay, you have to neglect, then only you have to start the procedure. Okay, so whether is there, like, see, now what we have 1, 2. Then you have to find 2, 1. Is there 2, 1? Check. No, there is no 2, 1. Just by just looking at one even you can conclude. Okay, just when you have to take one ordered pair you have to take, and you have to see whether is the symmetric ordered pair is available or not. You can see that there is no symmetric ordered pair, so the answer is no. Okay, so not this one also. Next is option B. Sorry, option C. Not option C. We are just checking whether it is not. Next is reflexive relation. Okay, so reflexive relation. Okay, so for reflexive relation, how it should be? It should be like all of these should be repeated like this. 1, 1 should be there. Then 2, 2 should be there. Then 3, 3 should be there. And also other than that, other ordered pairs also should be existing. Okay, it can exist or it need not to exist. Okay, so reflexive relation or not, that you have to check. See, all these exist. All these exist. Okay, and also along with that you are having these 3 extra things. So yes, this is reflexive. Okay, so this is a reflexive relation. Okay, next is option D. So here what you have to check is you have to check whether it is transitive or not. Transitive relation. So how will you check whether it is a transitive relation or not? If A is being related to B, then B is also related to C. Okay, then B is being related to C. Then if there is, okay, and if there is A is related to C, if this is there now, then we can say it is transitive. So how can you write, like in terms of the ordered pair? If I'm writing now, then it will be A comma B. Here will be B comma C. Then here will be A comma C. Okay. How will you check? Now we have got these 3 ordered pairs only, and as I said that in order for transitive and for reflexive you should not take this. Okay, these 3 you should never see. Only these 3 you have to check. Okay, so you have 1, 2. Let 1 be, okay, let A be 1 and B be 2. Okay, then C be 3. So this will be A, this will be B, this will be C. Okay, so now what you have to check is A comma, okay, so see 1 comma 2 is there. Okay, 1 comma 2 is there. That means 1 is being related to 2. Okay, so 1 is being related to 2, and then 2 is being related to 3, and also you can see that 1 is being related to 3. So this is applicable. You can also substitute if you want. You can substitute in place of A1, in place of P2, and in place of C3, and then you can check. Okay, so yeah, it is transitive. Okay, so it is transitive. Okay, so now we have completed this. Next is, yeah, we have seen what is equivalence. This is some other thing that we have to check. Okay, so now what we are going to do is we are going to talk about another question. Okay, this is kind of like bit higher level. That is, okay, they have given R is equal to X comma Y, okay, where X and Y are integers. Okay, X and Y are elements of the set of integers. Okay, here integer is the universal set, comma X square plus 3Y square is less than or equal to 8. Okay, so they have said that as a relation on the set of integers. Okay, so we have to find the range of R. Okay, so is a relation of set of integers. Okay, One second, I'll check the question correctly. Okay, so this is for inverse. Okay, this is actually they have asked us to find something different, so we will change this question a bit. So here we will put erase this and we will erase this, and then yeah, then everything is same. Okay, here 4 should be there, and what they are asking is they are asking the domain. Okay, so what is the domain? Now you can see what is the equation that they have given, that you have to write in separate, that is x square plus y square is less than or equal to 4. Okay, so this is what something that they have given. Okay, so what you have to do is you have to put values. Okay, let us take that we are going to put some values in place of x. Okay, in place of x we are going to put some values, and then we are going to check. See, once again, this is a condition. Okay, this is a condition where this is what a function is. Okay, so where if you are giving here, okay, which is x is what the domain, right? So if you are giving the input, then you can get the output, okay, which is the range. Okay, so this is the domain. Okay, now what you are going to do is you are going to put some values and you are going to check whether can we put them or not. Well, generally for these questions they will be giving you options, and in that options you can take that options and then you can put in the question and then you can easily find the answer, or else you can also do like this. That is, so I'm going to assume a few values. So first let me assume that x, okay, what they have asked is, okay, the domain only, yeah, so the domain only they have asked is, I've just checked it once. Now we are going to put some values. First let me put in place of x, let us put 0. Okay, so if you are putting 0, then what will be? It will be 0 square plus y square, which is 4, so it is going to be 2. Okay, so it is going to be 2. Okay, so plus or minus 2 in sense, then y can be what? Okay, y can be 0 plus 1 minus 1 plus 2 minus 2. Okay, so that means if you are putting in place of x, wait, okay, 0. If you are putting over 0, then what you will be getting? You will be getting 0 plus 1 minus 1 plus 2, then minus 2. Okay, then now I'm going to put in C plus 1. Okay, plus 1 and minus 1. Since square is here, okay, since square is here, it doesn't matter whether it is plus 1 or minus 1. So if you are putting plus 1 to minus 1, okay, then now you check. Okay, then y is going to be what? This will be the ace. Okay, so it will be here 1. Okay, no matter it is plus 1 or minus 1, it will be 1. So then y square will be less than or equal to okay, so it will be less than or equal to what? It will be less than or equal to 3. Yes, right? Okay. So then y is less than or equal to 1.7 root over value of, okay, it is like around 1.7 MB. So that means you have to choose an integer. Okay, you have to choose an integer which is less than 7. Okay, and also, yeah, here plus or minus 7. Yeah, so you have to choose an integer which is greater than minus 7, and then you have to choose an integer which is less than plus 7. Okay, so what integer will be there? 0 will be there, plus 1 will be there, then minus 1 will be there. Okay, so what will be there? 0 plus 1 and then minus 1 will be there. Then other than this, still we will do one for only 1. Okay, only 1, and then we will put one value, then we will find. Okay, that is going to be plus or minus 2. Okay, so now I will do one, we will do one, we will see. Okay, so in place of here, okay, so here it will be plus or minus to the whole square, so it doesn't matter, which will be 4 itself, so 4 will be cancelled, it will be 0, so y should be less than or equal to 0. So here you cannot choose anything, here you cannot choose anything, here you should not choose anything. If you choose, then it is wrong. Okay, so that means when you are putting over there plus or minus 2, then what you will be getting? You will be getting here 0. Yes, right. So you will be getting a 0. Now try with some other values. Why don't you try with plus or minus 3? Okay, so that means here you can see that it will be exceeding, because here it will be minus over here. Here it will be minus. Wait, I will say y. Here if you are putting here 3, okay, so plus or minus 3 the whole square plus y square is less than or equal to 4. Okay, is less than or equal to 4. Okay, now what you are going to do here, you are going to plus or minus, you will neglect since square is there, and 3 square is going to be 9, so here will be 9. Okay, then y square is less than or equal to 5. Okay, minus 5. Now put root y is less than or equal to root over minus 5, which is indefined. Okay, which is not correct. Inside root, you should not write any integers. Okay, any negative numbers is not at all allowed to be written inside the root. Okay, so this is not correct, so that is why you are not supposed to put there plus or minus 3. So if plus or minus 3 itself, it is not applicable, and then just think about for plus or minus 4, so it's not applicable, right? So the domain, okay, these x is what the domain is, so you can put 0, you can put plus or minus 1, and you can put also plus or minus 2. Okay, so by using this condition, we have first put some values, and then we have checked whether are those values satisfying this condition, and we have come to know that yes, it is. So the answer for this question is that domain. Okay, so domain is going to be, okay, so I thought there will be some sort of history for this question. No, there is no history for this question. The domain is actually 0 plus 1 minus 1 plus 2, then the minus 2. Okay, so this is what it is. Perfect. Now at last but not the least, this is some other thing. Inverse relation, very important. For what? For one upcoming chapter, we are going to completely discuss about this inverse relation, and for this inverse function only. What is that? It is going to be inverse trigonometry, ITF. Okay, this is very important for that chapter, which is inverse trigonometry, where for that you have to know inverse functions, and for inverse functions you have to know inverse relations. Okay, before that we will say one small thing alone. I have to say one small thing, that is, for an example, okay, so I'm going to erase, so I'm not going to write it in a neat, okay, no, I'm not going to erase, there is also important. Inverse of an ordered pair. That is, for an example, you have got x comma y as an ordered pair. The inverse of this ordered pair is going to be, okay, is going to be y comma x. Okay, is going to be y comma x. This you have to know. The inverse of an ordered pair is just the shuffling of this. This will come here and this will come here. Okay, that's it. Just you have to shuffle them. That is what the inverse of an ordered pair is. Okay, next is inverse relation. Maybe you would have studied a little bit about this in your class 11th itself, as if your teacher is someone who is not a person who will be just constructed towards just the NCERT part of class 11th, who is also a person who can teach like still like in a better way, like that means more than NCERT, okay, higher level than NCERT, then he would have taught about this inverse relation. I'm not saying that teacher is bad, this teacher is bad. I'm just saying that maybe you would have got the chance to learn it in your class 11th itself. Okay, so inverse relation is very simple. Before that, one key point I'm going to say here, if I explain, you will not get it. But inverse relation and inverse function are very similar. Okay, their difference is like x tends to 0. Okay, their difference is x tends to 0. So I can also say that all inverse, okay, all, I'll write in a different color so it will be highlighted. So all inverse, okay, so all inverse functions are inverse relations, but vice versa is not applicable. Okay, is not applicable. That means not all inverse relations are inverse functions, but all inverse relations but all inverse functions are inverse relations. Okay, now what we are going to do is we are going to see one concept you have to know, that is, for an example, you have got a normal relation, okay, a normal relation that is going, and then an inverse relation that is going. If someone has asked you, okay, to change one normal relation into an inverse relation, then what you have to do is just remember these 2 points in your brain. Okay, just remember these 2 points. If you think a bit, okay, little bit, then you would have already got the answer, because this concept and this concept are very same. Which color shall we use? We shall use this color. Okay, see, domain, let us take, there is domain of A. Domain of A, where A is the set, and range of A is there. Okay, range of A is there, right? Okay, so in order to change something, what you have to do is you have to substitute, you have to change, okay, how can I say, wait, I'm thinking of the representation. Here we will write domain, here we will write range. Which color? This color is okay. Now that is same color only, oh, it's okay. So now what you have to do is, let us assume that domain of relation is x. Okay, domain of this relation, okay, domain of A, let that be A. Okay, A is x and range is y. Okay, but in case of inverse relation, you have to just swap them. So that means domain would have got converted into range, and range would have got converted into domain. So here y, here x. That means, for an example, what we are going to do is for tan theta. Okay, so for tan sine is what easy. Okay, so for sine theta, for this you have to know what is restricted part. So for that you have to know what is inverse trigonometry. So what we are going to do, okay, so I'm going to give you an example. Where relation is given like 1, 2, then 2, 3, 1, 3. Okay, so this is something that they have given. 1, 2, 2, 3 and 1, 3. Okay, what is this? This is transitive. This is transitive relation, but we are not going to check that. Okay, so now they are asking you to find inverse of this relation. What do you have to do? Here first find what is the range. Okay, what is the domain? Sorry, what is the domain? Domain for this, I'm going to erase this also. Okay, so domain is 1 comma, okay, 1 comma 2. What is range? Okay, so range is 2 comma 3. Okay, so it is just going to be inverted in the case of inverse relation. That means domain is going to be 2 comma 3 and range is going to be 1 comma 2. So then write inverse relation in terms of ordered pair. Then it will be 2 comma 1, it will be 3 comma 2, and at last but not the least it should be 3 comma 1. Okay. Okay, now we are going to see one more concept, that is okay. Now we are going to find another concept, that is, yeah, from here we have completed. Now we are going to jump into functions. Okay, now we are going to jump into functions. We have completed vertical line test, horizontal line test is there, that we will be seeing in one function. Now we are going to see about types of functions. Okay. Functions. Before that, I'm very hungry. I'm going to eat something and I'm going to come.